I lost my place again, but I was about to say that now you can take that value of 0.255 that we had at the end of this calculation and cross-check it on a table of coefficients, because you know that the first material is rubber. So you can see up top here, there's a whole bunch of rubber possibilities. Rubber on concrete, rubber on asphalt, and then there's even conditions, dry and wet. So I'm just looking over here at these values, and I'm looking to see where our value of 0.255 could possibly fall. And if you look at those, the first three are actually, it doesn't even fit in this range, or that one or that one. They're all too high. So actually the only possibility here is the second material must be asphalt, and it actually has to be wet. Even the dry version of that won't work. So it's definitely answer C, you can write on your pages, definitely rubber on asphalt, and it has to be wet. Two examples definitely are not enough for friction. So remember what I always say about questions in this class. On your practice question page, we're going to do 4 questions, but I don't want you to think of these as homework questions where you cram the answer as small as you can on the page. You need more examples. So I want you to think of these as example 3, 4, 5, and 6, and do them slow and do them large, leave a lot of space for taking them up. The first 2 questions on here, number 1 and number 2, they're not going to do anything more than use the force of friction formula. Force of friction equals coefficient multiplied by normal. The first one gets you to rearrange the formula, but we just did. It's the same rearrangement. And the second question, you don't even have to rearrange. But those first 2 questions are really just formula practice. It's not until you get to question 3 and 4 that there's a situation behind the question where you have to figure out all different little things like we did in these 2 examples. The nice thing about question 3 is it doesn't leave you stranded with one question and a whole bunch of things to calculate. It steps you through it. So it tells you in part A and part B and part C what to calculate. So it's going to be just like example number 1, but the difference is when you get to part C, it's actually going to go a little bit further, because example number 1 stopped when we calculated the acceleration. This question, once you get the acceleration, you get to part C, and it now wants to know what's the distance that the object will move if it starts from rest and accelerates for 5 seconds. So see if you can get that answer. And then in question 4, a slightly different situation. It's still a friction question. But in question 4, and this is very noteworthy, so make sure you do question 4. In question 4, there is an object, it's a hockey puck. It's sliding across the ice. So you have a 0.170 kilogram hockey puck sliding across the ice, and it's coming to a rest, so it's slowing down. This is a situation that confuses everybody the very first time you do it in grade 11 physics. There's no forward force. I mean, usually we do this. Usually we write on an applied force. But an applied force is muscle power or engine power. And this question, that already happened. There was muscle power that got the puck into motion during the slap shot, but that was when the puck and the hockey stick were in contact. That's over now. The puck is sliding. So there is no applied force, and that's okay. There doesn't have to be a forward push, but if an object is moving, there will be friction. So there is going to be a force of friction between the puck and the surface. Net force is always considering the forces in the left and right direction. So usually net force looks like this. Usually net force is, and again, there's no formula for net force, but usually when we build one, we usually take whatever the applied force forward is and you subtract off friction. Well, that's okay if there's no forward applied force, or if the forward applied force is 0. That's fine. You can still calculate the net force. It's just not going to have anything in it but friction. And that's a very normal situation. I don't want to use the word normal because I don't want to confuse it with normal force. That's a very regular situation that you get questions where sometimes the net force only has friction in it, and that's it. So they're not the same force, but the numerical value of friction when you calculate it is going to be the same numerical value for the net force in this question, because there is no other force to consider. And see if you can complete the question, because the question acts the same way. Everything else in the question is the same as example 1 and even question number 3. The only difference is it's actually a little bit simpler of a question because you don't have to do this calculation. We're going to take all 4 of these questions up. I'm going to post solutions, of course, even if you missed the actual take-up. And as I say, do these questions with the intention that they are further examples, and hopefully that focus will make your notes neater than if you thought of this as doing just 4 homework problems.